Surface waters are polluted with considerable amounts of pollutants, which cannot be appropriately removed by conventional cleaning technologies. Photocatalysis-based titanium dioxide is a promising advanced oxidation technology, which has been widely used in a variety of applications, including water purifications, bacterial disinfection, and self-cleaning surface. Therefore, the demands of global market continues to increase in the upcoming years and reaching to $5.3 billion in 2025. However, one of the drawbacks of pure titanium dioxide is it can only be activated by UV illumination. This problem leads to a considerable increase in the application cost.
The present study addresses this problem by modification of titanium dioxide with the nitrogen and silver element. Doping with nitrogen is one of the strategies in order to extend the light absorption of titanium dioxide in the visible region by narrowing the bandgap energy. Meanwhile, the incorporation of the silver nanoparticle on the surface of catalyst is able to extend the lifetime of the charge carrier. In addition, the silver nanoparticle also display an antibacterial effect toward wide range of microorganisms.
Typically, when the catalyst is illuminated by light, the electron jumps to the conduction band by leaving hole in the valence band. Then, the photo-generated electron transfers to silver nanoparticles and suppress the recombination process. The surrounding oxygen molecules can capture the electrons to form superoxide anion radicals, and water molecules react with holes to form hydroxyl radicals. These reactive oxygen species have strong oxidation potentials and can decompose various organic pollutants and bioresistant materials into harmless products. The photocatalytic study shows the catalyst is able to degrade about 100% of hydroquinone under visible illumination. The antibacterial effect of catalyst fixed on the surface of plastic sheet is identical with commercially available self-cleaning surface of plastic sheet. Therefore, this catalyst proves to be potential for both photocatalytic and antibacterial application. For more detail, please check out our paper. Thank you.